Once again, good morning, everyone, and welcome to another SoCalGas research webinar. Today's webinar is titled An Inflection Point for Global Pipeline Safety and Integrity, and we are excited to welcome as our main speaker, Mr. Cliff Johnson, President of Prci. My name is Ed Newton, and I, along with Hugo Mejia, will be your moderators for today's webinar. I am the Gas Engineering Programs Manager for SoCalGas, and I manage the gas operations R&D portfolio and program. And Mr. Hugo Mejia is the SoCalGas Engineering Hydrogen Manager, and he will be sharing a few of the projects being managed by his team. Next slide, Hugo. So before we begin, I'd like to walk everyone through the GoToWebinar toolbar that everyone should have on their desktop. There's a number of drop-down menus to help you control your audio and your webcam, etc. There's also a section for questions. So during the presentation, if you have any questions, please type those in and we'll cover those at the end of the presentation under the Q&A period. There will also be opportunity if you want to ask a verbal question. To do that, please click on the raise hand icon during the Q&A session. And when you're called on to ask a question, then we will first grant you access to unmute, and then you will manually unmute yourself. And then please go back on mute after asking your questions. And then finally, you'll find a few valuable documents in the handouts box, which is also on the drop-down menu. Next slide. So the SoCalGas R&D program is structured with about 5 different sub-programs. The first is the low carbon resources, and it focuses on renewable gas production, carbon capture, and utilization and sequestration research projects. The gas operations portfolio, which I manage, covers environmental and safety aspects of the operating organizations within SoCalGas, our operations technology development projects, projects related to system design and materials, and system inspection and monitoring. We also have a clean transportation research portfolio where we cover on and off-road technology development, refueling stations, and onboard storage technologies. And then we have a clean generation portfolio that covers integration and controls and distributed generation. And then a customer and use applications portfolio that covers customer food service, residential and commercial applications, industrial process heat technologies, and advanced innovation for end use applications. Next slide. I just wanted to make a couple comments about SoCalGas's commitment to diversity. SoCalGas is dedicated to improve the quality of life in the diverse communities that we serve. To support this commitment, SoCalGas R&D staff conducts outreach efforts and activities to engage with disadvantaged and underrepresented stakeholders within the communities throughout California. We notify researchers and entrepreneurs and businesses about RD&D program funding opportunities. We share the results from research projects to inform and educate the general public. And such as today's webinar is an example of one of the ways that we do this. And we track and report progress in diversity outreach efforts to our communities in our annual research report. Our annual research report on the next slide is published annually, and you can find more details about the SoCalGas R&D program in our current year's report, our 2021 research activities, and that's also included in your handouts today, as well as a Spanish version of the research report to help connect with the diverse communities within our service territories. And next slide. Finally, we'd like to stay connected with our stakeholders in the research community and general public. We encourage you to visit our webpage, which is located here on this slide, where you can find our annual report, which I just mentioned, which provides information about our upcoming webinars and news about the R&D program. You can also reach out to the R&D program team via email with questions, comments, or research suggestions. We also maintain an R&D webpage on LinkedIn and on the CEC's research networking platform, Empower Innovation. And with that, I will now hand it over to Hugo Mejia to say a few words about the work being done at SoCalGas on hydrogen. Hugo?
Hey, thank you, Ed. Appreciate the introduction, and just a general note to the audience, if you have a chance, take a look at the RD&D report. It really demonstrates and shows a lot of the great work that's currently happening in the energy space. I'll turn off my camera. So before I introduce Cliff, let me provide a little bit of background on why we're working with Prci today, and more importantly, or not more importantly for me, Emerging Fuels Institute. As you know, California has an aggressive and ambitious goal for climate change and being carbon neutral by 2045. And in alignment with that, Southern California Gas Company issued its Aspire 2045 commitment goals last year. And a big part of the work that we're looking at is really with hydrogen to be part of the solution, and other clean fuels. But today we're going to focus on some of that work there. So why hydrogen? Just a little bit of background. It's one of the most abundant elements in the world. It can be produced in a 100% sustainable way. It's also an excellent solution for long-term storage. So I think we feel that hydrogen could play a major role in the carbon-free economy of the future. So before I get into some of the details, one of the areas we're looking for hydrogen is hydrogen blending into our existing system. And before we go into that effort, and there's a lot of knowledge gaps that we're working through. We want to be focused on safety, system integrity, and system reliability. And it's really these knowledge gaps that lead us to work with a newly formed group in the pipeline in Prci, which is Emerging Fuels Institute, and it's a common interest for the entire energy industry to fill these knowledge gaps and work together to resolve these as we move not just SoCalGas, but really the entire energy industry into this arena. So quick introduction of Cliff Johnson. Again, he is the president of Pipeline Research Council International. It's an organization that SoCalGas has been partnered with for several years. We partner on challenges within the industry and to help resolve those on the research side. And then more recently, Cliff has been the lead in developing an Emerging Fuel Institute, which is focused on several aspects of emerging fuels. And Cliff, before he joined Prci 12 years ago as president, to continue to lead the organization in the research arena. Prior to that, he was at NACE as the Director of Public Affairs. And with that, I'll turn it over to Cliff.
Thanks, Hugo. Thanks for that great introduction. It's really an amazing time to be here, and there's a lot to think about in our space and how we want to do this and where we want to go exactly. When we think about the where we are as an industry, we're at this unique crossroads. I call it the inflection point of the need to be able to service both the existing assets as well as the long-term future for the next fuels that we're going to be going through. So this is where we're trying to pull in today. It's really, where do we go and how do we do this, and the need to be able to do both of these clearly and sufficiently. What I'm going to do is turn off my my camera to make sure we have the bandwidth for our presentation today, and to give you guys the best opportunity to see my slides. Just make sure I get them up properly. There we go.
Hopefully we're seeing your, there you go.
There we go, got it all squared away, perfect. So, whoops, what's the slides again? Do you guys see the full screen? Probably not.
It just switched back.
Let's just switch back. It's the cantankerous computers this morning. There we go. So what I want to do is spend some time talking about where we've been as PRCI and where we see the future going. As Hugo mentioned, we've just recently launched the Emerging Fuels Institute last year. And at the time, in the US at least, it was one of the few conversations about aggressively moving to this new reality. But it's something we need to think about on both parts of the equation. So today we're going to spend time in looking at the fullness of where we're going as PRCI and how do we need to make sure the industry is supported. We are 70 years old this year. We've been doing pipeline safety and integrity since 1952. And when the 6 operators came together to solve one common problem, the thing that really bubbled out of it really is the idea that collaboration is the way to make the system safer. Collaboration is the way to strengthen the integrity. And collaboration is the way to ensure the life of the asset for as long as we need it to be around. So those focal points, that critical comment of collaboration has now become the backbone of PRCI and has been since our inception of how we move this forward. Looking to partner with many people here on the phone, the companies and the industries, and even people outside of the oil and gas industry, reaching out to our public and reaching out to our regulators to fully bring in the ideas of what needs to be done and how do we move through this effectively and efficiently. Looking at that from a collaborative point of view, we can get to the next future. We can be the ones who help move and transport the next fuel, whatever it may be, and we are the ones who can ensure the integrity of the current assets to ensure that we have hydrocarbons as long as we need them. With that, let me give a brief who is PRCI. PRCI is the Pipeline Research Council, and some of the key things here to really focus in on is, on the pipeline side, we cover more than just the pipeline assets. That's the transport part of the materials. We also look at the associated facilities, underground storage, the compressor and pump stations in the research portfolio. We're one of the few organizations globally that look at the oil, gas, and biofuels, CO2, all in the research portfolio. There's very many groups who do parts of that, but not many who do what we do as a totality and the overarching look at it. When we look at the research component of PRCI, the key thing here is really the transfer of knowledge. We want to make sure the information gets out there and is used to ensure the integrity and the safety of these systems. Right now, today, pipelines is the most efficient and effective way to move energy in the world. With that opportunity, we need to make sure that this system stays as safe as possible. When you look at the council idea, what we're able to pull upon is the best and the brightest from around the world to solve the key problems that we have in our industry. Right now, there's many reports that will show you that the pipeline industry in the US is 99.99% safe. So I call it the 5 nines. How do we get closer to 100% accuracy? We got to keep pushing forward and be able to resource the best minds from around the globe helps us to do that. PRCI is a truly global international organization with members all across the world. The mission for PRCI is critically important. And what I would pull it to here is a few key words: relevant, innovated, and applied. We want the research to be something that really helps us today and not really looks to the long term. We do have some basic research that is something that will propel us for the future down 30, 50, 60 years down the road. But the majority of our portfolio is going to be application research for today's key issues to ensure that we're moving the hydrocarbons, the biofuels, hydrogen, CO2, and other energy sources into the future. This here is a slide I always throw in here. This is my graphic for myself. I love pictures, and this gives me that visual representation of the leading companies in the world who have joined PRCI to make a difference. We have 40 operators from around the globe who have committed to trying to make things better. Doesn't mean they're flawless, doesn't mean they're perfect, but it does mean they're working constantly to continue to improve to enhance safety. When you look at this and our partnerships that we have, PRCI represents approximately 60% of the world's transmission pipelines. Let me say that again. PRCI represents 60% of the world's transmission pipelines. This is a unique opportunity for our organization and a big responsibility to define and to do the research that is needed. With that kind of mileage in the organization, we should be the ones who are the go-to sources who say, here's what the problems are and here's how to answer them. And that's what PRCI is doing today. More needs to be done. There's operators who can continue to contribute to this and continue to be partners with us. And so we're reaching out to continue to grow this network of members, to continue to expand that responsibility, that desire for perfection, that opportunity to have zero leaks and zero emissions is what we're all striving for. So let me shift now and talk a little bit about how do we do the things that we talk about? How do we create this ensuring for integrity? Where do we go? How do we make sure these systems are safe? We're embarking on a 3-year plan. We decided we usually have a 5-year plan. We all have familiar strategic plans. Ours has been 5 historically, but the pace of change in our industry, we want to be more agile, more efficient, and more effective for the industry and do a 3-year plan. Looking at our core research, this is what we've been doing since 1952 to ensure the integrity of the hydrocarbon pipelines. Critical assets that still need to be there. Any study, which I'll talk about a little bit later, shows they're going to be a key part of the energy mix for many years to come. And that energy mix is a critical concept I want to make sure we come back to. Technology centers. PRCI has established a physical resource in Houston, Texas, to allow us to test, validate, and verify various parts of our industry, from tools to training for professionals to the integrity that's needed to advance us. We're looking at ways to bring in samples, pipe samples from around the globe with key industry defects that allow us to move a little bit further forward with having real tests done there in a controlled environment. We are embarking this year on a new initiative that allows us to look at the data. We talked about the physical asset in Houston just now, but we also look at the data and really share what that looks like. How do we begin sharing amongst all the operators with all the knowledge that we have to advance us and pass the 5 nines? With the data, we'll be able to do that and be able to leverage that some more. And then finally, PRCI has put into words an environmental commitment. This has been the backbone of our organization since our founding. We wanted to keep the product in the line as long as physically possible, as long as we can possibly do that. And if it ever gets out, we want to find it soon. So that environmental concern, that environmental focus has always been part of our ethos. But now we wanted to define it and really specify what we're trying to do in that space, which we'll talk about quite a bit today. From an organization point of view, how we move through all this is through our technical committees. This is where the research is done and really driven, is really on the nuts and bolts of the operations of these key assets. There's 8 technical committees that support our conversation, ranging from corrosion all the way to surveillance operations and monitoring, looking at the facility side, the compressor and pump stations and underground storage. Each of these takes a different piece of the problems that we have to advance integrity, looking at issues from third-party damage. This is when someone comes along our pipeline and hits it with a backhoe when they're trying to do construction or other activities near the sites. How do we minimize that? If a product escapes from the line, how do we find it as soon as possible? How do we mitigate that loss? How do we understand what has happened? How do we create tools that keep the integrity understood on an annual basis so we can do continuous monitoring through the process? From those technical committees, we've developed a series of things to help us guide our research programs as far as priorities and objectives. Here, we'll talk about the research priorities, which look at crack management. That's what CM stands for. How do we understand the cracks and their impacts on our systems more rapidly and more effectively? Cracks were really one of these things that are very challenging for our industry, and we need to continue to evolve the tools and the process around it. The next one, there's mechanical damage. This is, again, that third-party strike when something impacts our system that isn't a planned experience, either during construction or after it was in practice. How do we manage those systems? Do we need to immediately pull them out of the ground, or can we mediate that impact and really move through that process? How do we detect the areas around that is what we're working on here. And the last one there, GHG, is the greenhouse gas emissions reduction, excuse me. This is something that we've been working on aggressively for probably the last 15 to 20 years. We've now said in the next 3 years, let's establish some hard targets to help reduce greenhouse gas emissions by a fixed amount. and that's something that we're working towards aggressively. And these are some of the key areas where we're putting significant funds in currently. I mentioned the technology development centers. They're there at the bottom is the TDC, Technology Development Center, and then the VTDC, the Virtual Technology Development Center, which is the data-based approach. And as Hugo mentioned earlier, the establishment of the Emerging Fuels Institute, which is a key part of our environmental commitment to allow us to provide a laser-like focus on the needs that are coming up with this new series of fuels, from renewable natural gas to hydrogen to ammonia to whatever may be next. How do we do that? So this institute is allowing us to focus on that while the rest of the organization is able to focus in on the core research. So we have this kind of dual approach to integrity and safety moving forward for both these product lines. As I mentioned, we've created research objectives that support the strategic research priorities. So the research objectives really drive into what needs to be done and by when. And I forgot to mention as I began my presentation, the slides are in the handouts. So if you would like to have a PDF copy of the slides, they're already in the handouts. Sections there, so please feel free to download them and use them as you want. But here's the research objectives. One of them here in the United States, which was critical, is having complete comprehensive understanding of the materials that are in the ground. Our systems are very mature in some areas, up to 800 years old, depending where you are in the United States. We need to make sure we have the data and the records to maintain those to understand, because once you understand the basis of your systems, every integrity decision after that makes sense. So really getting a strong quality situation. Majority of our operators have a high level of knowledge of their systems, but we want to get to 100% knowledge, a flawless understanding of what we have in the ground, so we can create adequate and efficient integrity programs. We have a series of tools that are kind of the backbones of our integrity process. One is dealing with inline inspection. These are the tools we put inside the system that are then able to monitor the health of the system as it goes through and report back to the operators what we need to do. These tools need to have the opportunity for continuous improvement, that we've had them in place. Aggressively began using them probably back in the 1950s and 60s, and now we need to continue to build on them and continue to strengthen, especially as we move into these new fuels. How will these things that we've built for hydrocarbons be impacted by the next generation of fuels, whatever it may be? So this is something that we would continue to work on. It's not just the tools themselves that we need to improve. It's also the data analysis and the human factors, the people who read and run the tools to make sure we do this effectively and efficiently. So this is really working on the inside of the pipe, running tools through. The next research objective is very complementary. This is called the non-destructive evaluation area. And this is technologies outside of the pipe, as you can see from the picture. And they're done as a complementary to the inline inspection. So inline inspection tools will be run on the inside. They will identify a number of areas of opportunity for us to explore and say we need to go see if there's an issue there. Then we'll go back in, dig a hole, and bring in the NDE and say, validate, yes, there is a challenge here, or no, there isn't. And we need to make sure we understand what we're finding. So we need to make this tool get even stronger as we increase inline inspection to get it as well. Again, it's not just a tool, it's the people and processes around it as well. The next thing we want to do is the fitness for service. I mentioned the vintage of our pipe. So we have some pipes in the ground from 100 years ago, some even older. Just like a couple of summers ago, there was the pipe pulled out of Chicago from the 1850s, excuse me, to be precise, that had been actively used since that period, that was being decommissioned to be hauled in a new, larger diameter system to push more product through. And so we need to make sure, how do we validate the integrity of these very mature systems that are still vital? If we maintain steel properly, it can last for a very long time. But this is part of it here, is that fitness for service. How do we know what we need to know for the integrity and the safety of our systems around the globe? The next area we want to begin looking at is really, how do we understand the repairs? We put in some key repairs into our process. We put in materials all around the steel to really shore the defects that we find. When we shore up those defects, how do we know how long that integrity of the repair is going to last? And we've been doing a lot of studies here in this space to validate how strong, how well these key tools work for us as doing useful repairs. The next thing we want to really think about is, as I mentioned before, the mechanical damage is part of this, is third-party detection now. When there's something along the right-of-way that doesn't belong there, and as many of you may know, there's pipeline corridors. These are areas where the pipes are laid, and then there's a space around each of the pipeline areas that are corridors for the pipeline safety. How do we know that along those corridors, when there's an event where there's somebody who doesn't belong there, that we need to be aware of? As I mentioned before, it's very commonly construction Someone's building a new community, a new development, a new road, and happens to encroach on this right of way. How do we know when they're there so we can make sure we align where the pipes are, and so whenever there's construction being done, it doesn't interfere with those pipes to create that safety barrier. This is a kind of unique. It's really kind of multi-level, from a ground-based inspection. How do you do the sensors along the way, to a aerial surveillance, looking at using planes and unmanned vehicles to monitor those things, to even space and using satellites to really kind of do time over time delivery. What is the impact here? Not only is it third-party intrusion, but it's also the movement of the ground. There has been a number of instances, unfortunately, most in recent times, with ground movement, so earthquakes, mudslides that have impacted the pipeline systems. How do you know what's going on there? How do you do those inspections? So looking for third-party detection and for geohazard ground movement to the future. This here is really talking about leaks and how do we find the leaks as soon as possible with the various different technologies. As you can see here, there's a picture of an unmanned vehicle, a drone, that will be part of the equation. How else can we do this? And again, how do we know there's a leak before it becomes super impactful to the area around it? How do we identify that quickly? This is what we're talking about here, and to really get into it both for the pipeline itself, but also then for the storage facilities, to make sure that the storage facilities are well understood too. We began looking at really the life cycle and really looking at how do we get the compressor and pump stations and the facilities associated with the research, the transport storage of our product. It's important that these facilities are working at an all-star level. We need to understand what is being impacted there. There is a number of opportunities in these facilities to have different releases because there's a lot of things that are manufactured and put together. Pipelines are long runs of steels with few connection points. The facilities have a lot of different connection points within them. We want to make sure each of those areas have areas that have been really well explored for leak detection, really gone after that. Also, you want to make sure that everything that you've put into the system goes through the system. And that'll help you another way to understand leaks along the way. If you don't have it gathered before, you'll see it here at the facilities as it comes in and does a transfer of custody and measurement structures through that. And then finally, I mentioned before the need to understand the vintage pipelines and their fitness for service. Even newer pipe, we have to make sure we're putting in the steels and the processes that we need to do today to have the longevity that we plan for and need in these systems to have 50, 60, 75-year lives. So as we put them in, how do we make sure we get the right materials up front and the processes to follow through? I mentioned research priorities earlier. The three that we talked about before were mechanical damage, crack management, and greenhouse gas emissions reductions. We also have a handful that we're beginning to explore for the next round of SRPs, and really we begin doing. We'll be meeting with our executive assembly in September to talk about which one of these should we continue to advance. Looking at geohazards, as I mentioned before, ground movement and its impact on pipelines. Leak detection, making sure we find it before it becomes injurious. Pipeline of things is kind of a silly name, but really we're looking to do is, again, this is that data story. Can we bring in all the data that we have to continue to drive and advance our industry? The human performance. There is a component of all of this that is the human factors. When you look at what roles the humans play and how the personnel around the pipes have such a critical role. These aren't automated procedures at this point. We still have a very high human touch, which is great. We just need to make sure we can continue to advance them and train them in a way that we continue to challenge ourselves and advance our industry. So this is where we get the inflection point. So in the United States, as I mentioned, last year was kind of this watershed transition year. California passes 2045 ideas. There were some discussions in New York for 2030, pushes in Colorado for 2035. This all kind of happened last year. It's kind of really a response to some of the climate change issues that are going on. Our partners in Europe and other parts of the world have been a little bit further ahead of us and moving a little bit faster. But for us, it really started last year. And so we began to think, what does this look like? So the Energy Information Agency in the United States government began to explore this and say, where do we need to be going and what is our projections? The green line here on the screen is the renewables. And there's a lot of different things that go into renewables. But that's the renewables energy. You can see a huge uptick between now and 2050. But the brown line above that is really some of the petroleum projects, and you can see that continues to go up. The blue line is the natural gas. You see a continuous increase in that as well. The energy of our future is really a mosaic. There isn't going to be one dominant fuel source going forward. It's going to be all the above kind of answer: nuclear, coal, natural gas, renewables, and liquids. I think coal will continue to decrease, and the projections you've seen, even discussions recently in the last 6 months, you've seen even a stronger decrease than what you see on the current chart. but that's kind of where we're going, and it needs to be that way. There's an opportunity for us to do it. Now we need to be better about cleaner, and we need to be better about integrity all the way across for all of these to make sure we have the tools that we need. But the picture here just shows you, it isn't like we're going to switch tomorrow and hydrocarbons are gone and this whole new influx of renewable energy coming in. We do have a transition period we need to go through. I think at some point in the future, maybe 2070, 2080, you'll see renewables surpass the other fuels, but it'll be some time before we get to that point. This here, many of you may have seen this. This is just a snapshot I pulled off the internet that shows the hydrogen economy. And hydrogen right now is probably the big discussion point, but there's many other fuels that are being conversated right now also in the background. But hydrogen is definitely a dominant part of the story today, is what do we do and how do we do it? When you look at the left side is really where some of the hydrogen comes from. And it's important to look at the fossil fuels are part of the story. Nuclear is part of the story in creating the next hydrogen opportunity for us. Not only is it for creating the hydrogen, but also for energy production itself. So this is something to think about as we move through this process. So we're going to be looking at the transition now, and I want to kind of pivot now to some of the things that PRCI is doing to help the industry and our members move in this space effectively and hopefully efficiently as we think about what's next. Some of you may have seen this photograph before, but I want to remind everybody there is a critical infrastructure across the United States that is still the most efficient means of moving energy. And the energy to pipelines title is important to think about. It's not just hydrocarbons. And today's conversation is about repurposing too. Is how do we repurpose some of these assets to put in the next generation of fuels, whatever we're going to be looking at, hydrogen, ammonia, as I mentioned before, and others that are being conversated. But this is what you want to think about. There's other ways of transporting it. But if you want to think about safety and integrity, the best way is still by pipelines across our United States and around the world, to be honest with you. Kind of the next fuel, hydrogen, you can see this pivot point of how critical it can be and the many functions that it can play, from transportation to heavy industrial, and even to in personal home use is how we can even see this move into the future. When PRCI established our environmental commitment, there was 4 components to it. One is the greenhouse gas SRP. 2 is really creating the EFI, which goes into the transport and storage of the emerging fuels. So the emerging fuels is 2 fits there. We then had to think about and just recently created the CO2 Task Force, which I'll talk about a little bit later, which is a byproduct of some of the emerging fuels activities and something you think about. And then the advanced leak detection. So these 4 weave together to really help PRC and our members to push for a low carbon, low emissions future. And this is something that we think is critically important for us. So the Immersion Fuels Institute, as I mentioned, it was established last March. It has now grown to 14 members from around the world who are supporting this and really pushing aggressively for the research program to flourish in the areas that we need. Here's the 14 on the screen now. Enbridge, Saudi Aramco, SoCal, TC Energy, Williams, ATCO, ExxonMobil, GRTGas, Gas Uni, OTD, Operation Technology Development Group, PG&E, Shell, Storage, and Total. As you can see, it's a pretty global approach between US and Europe. There's a strong partnership that we've created, I'll talk about briefly in a minute, that really globalizes this push for us to sneak the best answers. So this is going to take all of us working together to really strive for the next generation of activities. I know here in California, there is a strong push between SoCal and PG&E and the University of California to put in for and support the Department of Energy's hydrogen hub, possibly in California, which is a great big step forward in here where the EFI is trying to figure out the best way to interface and support that. It'll be a key part of our story as well. PRCI has also set up a government collaboration focus on this. Last summer, we began a series of webinars and conversations and continued on this year with key organizations who will have oversight and regulatory push in this area and research, looking at the U.S. Department of Transportation's Pipeline and Hazardous Materials Safety Administration. This is currently the body that oversees pipelines in the United States for hydrocarbon transport, and more likely is going to oversee the hydrogen aspect as well. So we wanted to bring in them to the conversation last year. The U.S. Department of Energy is a critical research component to this, and we brought them into the conversation. Natural Resources Canada is kind of a sister organization to the U.S. Department of Energy. Again, another place that's going to do a significant amount of research to help drive this conversation. And then the Canada Energy Regulator is similar to the U.S. Pipeline and Hazardous Materials Safety Administration, PHMSA. They're the regulatory oversight body to really understand what we're doing in this space. So those 4 groups came together for the first time ever last summer in PRC. It's helped to facilitate the conversation to say, how do we do this, and begin the conversation of who needs to regulate what and how. Also, the reason to bring these 4 together is that pipelines in the United States don't stop at a border. Many of the operators I mentioned before in the US also have operations in Canada. So when they cross the Canadian border, they just don't stop there. So why don't have a partnership regulations? Trying to create the atmosphere of a partnership for safety and integrity. When we do this next generation of fuels, safety and integrity have to be the first conversation. And to do that, all the operators, the public, and the regulatory and the research communities need to be aligned together to ensure the safety and integrity. We can't go out there and kind of just figure our way out. We need to make sure safety is the #1 priority, and that's what we're doing right now. And so with this government collaboration, it's allowed us to set that platform to create the conversations that we need to say, how do we do this? So as I mentioned, we began meeting last year. We had 3 meetings last summer. We've had 2 more this summer to continue the dialogue and continue to advance that. The next series of meetings, we're going to look to bring in our European governmental partners as well to really advance the story with some of the things they've already seen, where they've already been, and how we can learn together and kind of grow. So that'll be the next evolution of this opportunity here. I mentioned the global collaboration earlier, and here's what it is. So these are a number of associations across the globe who are really helping us in the industry move forward. And I'm not going to read all of them, but I'll point out a few key ones. Upper left-hand corner is the Australian Pipeline and Gas Association and their Future Fuel CRC, which is in the bottom left. Those 2 organizations have really done a great job of looking at some of the end-use story on the research side. They receive about $10 million total from the federal government in Australia to really drive this. And this started about 3 years ago, almost 4 years ago now. And so they've got some great research in that area. They've begun doing some more infrastructure discussions, looking at the pipe and the storage. And so they wanted to partner with us this last year to help drive that conversation more effectively. On the right-hand side, you have EPRG, which is the European Pipeline Research Group, and then you have GERG, which is the European Gas Research Group. Those 2 have come together and really brought some money from the European Union and really driven some of the conversations there on how do we advance this. And they're pulling the discussion now into full-scale testing, which is actually taking pipelines, fully putting it in a hydrogen environment, and then destructively testing it and see how far it can go and really find out what some of the boundary conditions are. We've all begun doing a number of small-scale lab tests. Now the question is, can we go to full-scale? And if so, what does that look like and how do we do it? And so EPRG will do the first rounds of the full-scale testing this fall, looking at Italy, where they have the opportunity to do the facility there and really drive that conversation. But many of the organizations that you see on the screen, others have also been actively engaged in this, many of them are in North America, and driving the conversation from the American Petroleum Institute to Sandia National Labs, which is part of DOE, of really helping us drive this conversation and where we need to be going. This is a lot on the screen, but I want to point to 2 areas I want you to look at. One is the upper left-hand where the green boxes are. We did the state-of-the-art report that was completed in the winter of 2020. And these were the 8 areas, technical areas of needed research to look at. And as we begun to identify the research portfolio and to drive that space. And then look all the way down to the bottom right in that pinkish area, which says PRCI hydrogen blend and 100%. The ultimate discussion of the EFI is to produce a guidance document for operators for either looking at how do you blend hydrogen into the current systems, or if that's not possible, can you go to 100% and what are some of the constraints and opportunities there? So again, green boxes are important where you want to start with and finish with the pink. That's the idea of the screen. There's a lot here, a lot of other details, but so this will give you a quick synopsis. I want you to look at those 2 boxes and realize that's what we're trying to drive to. If we can achieve that, we'll have a platform for the industry to safely and efficiently transition to the hydrogen economy. That's the goal. And that's the exciting opportunity that we have as PRCI today. The next 2 slides are a list of some of the projects. I won't run through them in great detail, but I'll let you have a chance to kind of just look at them. But let's let you know there's a lot being done. We just started last March, but we've already got about 15 projects in the queue that are really significant to help drive us forward and to say, here's how you do the transport. Here's what you need to think about for underground storage. We are currently attempting to partner with PHMSA. They put out a research announcement last May, and they'll be making awards next month. And we're optimistic that we'll hopefully receive some of those awards to help us work with them in a partnership way, which we've always done, to continue doing the research program. PRCI and PHMSA has done a lot of work together jointly on the core program, looking on the base traditional hydrocarbons. And now we want to help transition into that research portfolio together in the hydrogen space as well. And this is what we're working on there. When you look at some of these things here, it's not only just, again, the pipes, but also the facilities, looking at the median and the gas quality. Hydrogen's been the focus of my conversation so far, but the next opportunity could also be renewable natural gas. This is biomethane, bringing in from different sources from really close by. And this would be a different kind of process because biomethane is probably going to be a local opportunity. But from an operator of a pipeline production point of view, your biggest challenge is what kind of constituents are coming into your system. So gas quality is the driver there. And we've been excitedly working with the Gas Technology Institute, GTI, on a database they created many years ago that we're now expanding with this hydrogen renewable natural gas focus of the constituents. And so we hope to have that database sometime later this year, the first part of next, that we can share with the industry as a whole of what are we doing and where are we going. So it's very, very exciting to see how this is coming together. We're also currently as active projects working with the Department of Energy on a small scale test on the impacts of hydrogen on piping. And so this is the first blush test in the US to understand what is it going to mean when we put hydrogen with these steels that we've been using for so long, and what's the impact. Most professionals will tell you in the oil and gas industry, they spent their entire career actively working to keep hydrogen out. Hydrogen and steel don't work well together. They create a thing called hydrogen embrittlement. But we know how we can begin going after it, and this we have done to keep it out of it because it's been the easiest way to mitigate it is to keep it out. But now that we're going to infuse it into the system, we now have to bring in some of the technologies, some of the ideas we've had before in the past to bear, plus create some new ones to ensure the safety and integrity of these new systems. So can you add it to the new things? Yes, we can retrofit. Is it going to be easy? No. Is there research to be done? Yes. Is it being taken care of? Most assuredly. So I mentioned the hydrogen, and we focused on the EFI, and we focused on the vision where this is going. The next thing that came up in discussions over this last year was really about CO2, and we hadn't really thought about that when we created the EFI, but it became very apparent very rapidly over last summer this was going to be a big issue, and so much so into the early winter of this year. There was discussions about depending on the kind of hydrogen that you're using, is it produced from natural gas? Is it produced from other sources? There's a huge CO2 component to it. With the production of hydrogen from natural gas, there's a significant CO2 challenge. And to do that, we need to find a way to mitigate that. And so the transport and storage of CO2 has risen to a very high level. Also, CO2 production is common in other industries. Agriculture has a big production of CO2. And so if we can find a way to help them mitigate its release into the environment and to store it, and to cap it before it becomes a negative in the climate change discussion, this is a huge win. So between the agricultural rising issue and the possible idea of using natural gas as the base feed source for hydrogen, the CO2 Task Force was developed. We've been doing CO2 transport and storage for a while in the US, but it's not a lot. We're talking about 5,000 miles. If you remember the prior picture I showed with the US infrastructure for hydrocarbon pipelines, it was a big scrambled mess of pipes across the country. Here's very discrete. You can see those 5,000 miles. We've done it. Now, so what's changed, Cliff? The big challenge here is that we're moving from a lower pressure system for most of these things, shorter runs, to higher pressures, longer runs. And so we need to think about it differently. So the variables have changed. So what we've been doing historically probably will work to some degree, but there is going to be additional needs as well. So we created the CO2 Task Force this past fall. And it's really a partnership between PRCI, the American Petroleum Institute, Association of Oil Pipelines, to really begin driving this on how do we look at and where do we explore what is needed for the CO2 and how do we look at this. The leaders for this task force have stepped up as Rick Norker from ExxonMobil, Wim Geert with Shell, and Clay Atwood out of Williams. So these three companies have identified this as an opportunity, one more thing to help with this climate change conversation and to really commit to that. We are closely working, as I mentioned before, on the other parts of the program, hydrogen and the core research. Also here, we're working with PHMSA on their recent research announcement on what can we do. Can we partner with them again? Hope to find out next month about getting that forward. If you wanted some more information about what we're doing and where we're going with this task force, reach out to myself or Tom Marlowe on our staff, and Tom will be able to walk you through kind of what's being done there as well. But this is a kind of a sister component to what we're doing in the EFI, because with the EFI, there will be some opportunities to think about the CO2 because of the type of hydrogen that could be produced. And also, that said before, to help mitigate some of the agricultural production of CO2, this pipeline, this storage mentality is going to be critically important. What I want to do for the next couple of minutes is talk about the technology development activities I mentioned before, and now here's the Technology Development Center. And so this is the base in Houston, as I mentioned before. We opened it in 2015, and really it began to show you what we could do and where the processes are. So we've got about 20,000 of workshop space, and another 9,000 of meeting space and offices, and about 8 acres, of test facilities around the structure. There's about roughly 1,500 to 1,600 pipe samples. These are important because for a long time we've been testing on a lot of samples in their industry. Majority of the time it's manufacturing defects, just because we didn't have an inventory anyplace of real world samples. And so what we've done here at the TDC is have a high inventory of real world defects from operators from around the globe that have said, hey, this is something that's really challenging for the tools that are running currently. Please put this in your inventory and we can begin testing against it. And so we're now able to put together a number of pull strings, which are long runs of pipe that we can then have the tools come through at full speed for the first time. When this was built, this was the first time that tools could get to full speed to test in real world experiences. And so this pipe area has really been a huge opportunity for us and a great advance for our industry to be rapidly testing tools in a significant way. We had a series of operators at one point come in and say, we want to line up this kind of sample set and do these kind of tests for a handful of vendors that we have not seen before. These are new participants in our industry. We want to validate their performance. Can they do that? This was a perfect setup for this opportunity. It worked out really, really well. So we range from 6-inch diameters all the way up to 40-inch diameters, which is the kind of the span of the industry of the pipeline. There's some smaller, there's some larger, but that's kind of the bulk is that 6 to 40 range. We also built on campus, not only do we have the pull strings, we also have a flow loop. And so the industry with natural gas, a pull string works out really well because when you have a gaseous environment, there's not liquids in there that you need to worry about for the tool. The flow loop then was created the idea to have an aqueous environment to test the tools that are comparable for the liquids industry. And so we now have that opportunity as well. And there we have a 6-inch and a 10-inch and a 12-inch opportunity for that. One of the unique things about this facility from other structures at the time was that we have the opportunity to pull spools out and put new defects in. And so as somebody comes in and says, hey, I have a new issue, here's where it is, we can change and modify our story. As I mentioned also for the people on the left, it gives you an idea, having professionals come in and see how the tools perform and what the data means. A lot of times in our industry, when you're newer to the field, you're used to seeing the reports given from the tools, but you've never seen the corresponding defects. And this gives it a one-for-one analogy to say, here's what the tool run looks like, and here's what the defect looks like, and go, okay, match them up perfectly, one-to-one there. This is the address. If you're curious about coming by the TDC, we'd love to have you come by. Just go on our website and we can have an invitation to come by anytime. I mentioned the Virtual Technology Development Center, and this really was started out of a recommendation from the National Transportation Safety Board. They wrote a recommendation to PRCI saying, are the tools as good as they claim? The tools being the inline inspection tools. Can they find what they say they can find through the process? And so we did a series of tests over several years, and we built the first pull string to say, let's begin validating and see what we can do. And so we brought all this data together. And so not only do the pull string was part of the NTSB thing, but the virtual information was as well. So we're able to get probably over 10,000 data points, 50,000 data points, excuse me, here on the screen, that really shows how these tools perform in these various defects. And this has really been a huge opportunity to see that yeah, they can do what they say. But it also said there was opportunities for continued improvement, to continue growth, and continue to push. And so the NTSB recommendation was out of the Marshall, Michigan failure back in 2010. So what did we learn is kind of the idea of how do we do data sharing and data learning. Our industry, the pipeline industry, has done a pretty good job of individual companies kind of working with their data. We haven't done a great opportunity of industry-wide sharing of data to elevate the industry. And this was something that came out of those original research projects that showed as we bring together stuff across all the operators, the more rapidly we can change and enhance. This is kind of a model that we've seen done very effectively in the aviation space and in the nuclear space. And so both those areas, their federal agency gives them the chance to share information amongst the various operators to advance the industry as a whole. That's something that we have not done consistently as an industry, and something we want to spend more time on and begin to look into see what we can do to build upon that. Currently, we've created a structure on our website, is the Virtual Technology Center. It's got two databases currently, one on pipe material properties, which I mentioned before as the core, as a research objective, number one. And so we now have a database of different samples and inventories. And so an operator can go in and say, I believe I have this information about my pipe. What do we need? What can I know about it? And this information database will begin showing it. Also, we have ultrasonic test results, and this is a testing method for the facility side of how we do this and some of the vibrations and calibrations we need to do. And we have the test results to show how different parts of the tools perform and which ones to use when. We're about to embark on a new project on river crossings. These are right-of-ways where there's a river and the pipeline crosses beneath it. And so what do we need to think about as an operator, and can we do common sharing? A lot of the corridors, a lot of the crossings have common, they're called common corridors, which means they have more than one operator. So multiple pipelines can be running through the same space under the river. How can those operators share information amongst each other? Or can they? Was the question we began with. And so we said, let's do this. Let's create a small project, and we called it a joint industry project within PRCI that looks at how do we do this. And then we said the things we need to think about is soil characteristics, water movement, various things that are very critical to the pipeline integrity, but aren't dealing with the pipeline integrity directly. So these companies can share that more easily and share what we're learning. And so we've now created a larger committee. We created a larger opportunity. We have about 14 operators now involved in the PRCI project to expand this and to drive this fully. We have members in the US and in Europe to help us kind of globalize this footprint, but really looking at what is there and how do we advance it beyond where we are today. So I've come to the end of the presentation and kind of wrapping it up, and I'd love to answer any questions you may have. And I see that the Q&A has been flashing as I've been talking. So I look forward to getting into those this afternoon. And so if there's some more questions, look forward to it. If you have any reason to get a hold of me and look forward to contacting me, please do. My phone number and my email is there. I'm always available. I look forward to spending time and sharing about the things that we're doing, where we're going, and asking questions about, is there something else we should be thinking about? Love to keep pushing that, because we're PRCI doesn't mean we have all the research ideas that we need to have. Maybe you see something that we're missing. I'd love to find out that from you and talk some more about that. Thanks so much.
Thank you, Cliff. A lot of great information that you've shared there. Hugo, are you still on? Maybe we can turn the cameras on. Cliff, I had one question before we get into the questions that have been posted. You know, you've shared a lot of great information. There's a lot of great research being conducted by PRCI. You know, maybe you can comment a little bit about the pace at which research is being conducted. And of course, the past performance is a good indicator of future performance, and the industry has made a lot of great advancements over the last 20 years, right? Since the turn of the century. Can you comment about where you see the industry, you know, going, and how fast that transition is going to be occurring as the research is being completed?
Yeah, it's kind of an interesting question, Ed. I'll kind of answer it in a couple different ways. We have a lot of opportunities in our industry, and we've been addressing them aggressively, as I mentioned, over 70 years. Research can take anywhere from 3 to 5 years to get solid answers. There's things you can drive in 18 months to get a solid answer. It depends on the depth of the question. In our new environment, what we're seeing, especially in the emerging fuel space, there's been some rapid changes and rapid decisions. And the big reason, the big success behind it has been the collaborative approach globally. So it's not just PRCI working in its own little vacuum. It's many of us working together to really drive it. So we'll fraction out the question. So the question says, can we move hydrogen in the current assets? Okay, great. So that's a huge opportunity to say, can the current steels move product? Well, so PRCI has picked it up, and we've ran with it on some of the questions. Then we turned over to the EPRG, the European Pipeline Group, and said, this is the space that you play well in, and how do you work it? So I think we're seeing more collaborative approach on the emerging fuel side. Now, on the core research side, we don't see that collaboration quite the level that I'd like to see. I think we need to continue working on that and continue to grow, but kind of average on both sides is probably about 18 to 24 months is a good research project. Now, it is research, so there is times you're going to get in 12 months in and go, wow, that was a really dumb idea. That can't be worked, so it stops. There's going to be other times you go, wow, I never even thought of that, and you go down a whole different other rabbit trail. And that's appropriate in research. But for the majority of the research, 18 to 24, very solid number.
Great, thank you for that. Hugo, did you have anything before we got into the Q&A?
No, nothing for me. Maybe a question for Cliff, just on projects. PRCI, EFI are involved in several research projects, but can you talk a little bit about research projects that go on that you're just monitoring and tracking, and how that feeds into the program?
Can you ask that again, Hugo? I'm sorry. I need to hear that one more time. I apologize.
No problem. So EFI and PRCI are involved in several projects directly, but there's research work going on outside that circle, and how PRCI tracks and utilizes that information to move, really to advance some of the areas you're looking at.
Yeah, like as I mentioned, the collaboration approach is going to be critical for us going forward. And so there is a number of quality research projects being done in PRCI. There's a significant amount of work being done in the Emerging Fuels Institute. I mentioned the global collaboration earlier. We're meeting about once every 2 months, every 3 months, to really align with what everybody's doing. Getting that understanding is critical. To meet the deadlines we have, 2050 sounds like forever. To be in research terms, it's tomorrow. It's really, but you're going to hear it before you know it. Several of our members in Europe, their timelines were 2030. Unfortunately, with the war in Ukraine, that timeline has shifted. Our member in Gas Unie in the Netherlands has been directed to be moving hydrogen by 2027, period. So that is the day after tomorrow. I mean, it's just right there around the corner. And then you look at 2050, it's maybe the end of the week kind of thing. We have to think differently. The idea that we can research and be methodical, we want to be good, we want to do great stuff, but we can't deliver it quick if we aren't working together as a collaborative approach. That's what I think we need to do more of. And we're beginning to do that. I've seen a lot more opportunities in that space, working with the Department of Energy, working on trying to create a partnership with GTI, the Gas Technology Institute here in the US. And as I mentioned, our international partners as well. I think those are things that are helping us move more rapidly than ever before.
Perfect, thank you.
Great, well, let's get into the questions. The first question is related to the Angeles Link project that SoCalGas has going, and Hugo, maybe you can comment first. It's how will SoCalGas assess and certify fitness for service for the existing pipelines chosen to prevent hydrogen embrittlement for long-term safety and probability? And then there's a reference to a Korean paper from the World Gas Conference. And then the question continues, or will Angeles Link be a new build of a novel line pipe highly resistant to hydrogen embrittlement, hydrogen corrosion cracking? What's the plan for inventing, testing, certifying that line pipe for hydrogen service with wind, solar source H2, which will inflict large frequent pressure fluctuations upon the pipeline?
Sure, let me answer the second part of that. Angeles Link is the current plan is a new pipeline, so it will be designed to hydrogen pipeline standards. And so that's, we're really embarking on kind of the front end of that work to start doing the planning for that. So a lot of details in terms of what the design is not complete yet, but that's something we're working towards, but it will be a new pipeline. In terms of fit for service for existing, that's really the work that we're doing with PRCI and EFI to understand it's not just the percentages of blends. There's several other factors that we need to consider before we can decide to put hydrogen in the system. And internally, we're doing an assessment that outlines and evaluates all the current data that we have on the pipeline systems, the vintage, the wall thickness, operational history, repair history. We factor all that in, and then we'll be able to really develop a kind of a ranking of where we need to make some modifications and changes, and which pipelines we think will be suitable.
Yeah, one of the things that Hugo mentioned about building a new line is due to standards, and the standard that we have is B3112, which is an ASME, American Society of Mechanical Engineers standard, and that is a good starting point. But as I mentioned before, like the CO2, we've been doing hydrogen movement as well in the country. But again, low pressures, low diameters, and so the current standard doesn't meet today's operational needs. The EFI is directly interfacing with ASME, and they just met with them 2 weeks ago in July to begin helping assist in the rewrite of that standard. And so between now and say middle to the end of next year will be the first working draft of a revision of that standard to help us, to allow us to move the levels and the volumes that SoCal and the team will want to be able to move in the new system for the Angeles Link. So that's going to be critical as we move forward with this. 100% hydrogen is going to be very, very vital. The blends are going to be a challenging thing, and looking at the different things, as Hugo said, there's a long list of issues that the operators need to think about as they begin thinking about which systems, which pipes they're going to move to this new environment. I mentioned that the work by Gas Uni by 2027, they'll be moving hydrogen. In Australia next year will be the first hydrogen blend line operated in Australia, and it's going to be on a system of ERW pipe. And for those of you who know what that means, it also says there's a trigger of question, can that be done? Most people in the United States wouldn't touch ERW and hydrogen together, but they aren't really having a choice in which systems they use. And so they're going to begin operating that next year, and we'll have a lot of learnings from that very rapidly on does this work and what can we do and what the pressure situations you need to think about. So some really interesting opportunities as an operator looks at, do they go to 100% or do they go to blend? And I saw a little bit later, I kind of cheated Ed to some of the questions, and saw a little bit later there's a question about some recent research by Chris Markey. He has made a very good observation that even 1% hydrogen puts a question mark into your system. So the blends are possible, but there's a lot of things you have to do from a technical engineering point of view to ensure the integrity and the safety of the systems. And as Hugo pointed out, knowing what your system is before you introduce hydrogen at any level, whatever level it may be, is critically important.
Yeah, great answer. And that gets back to your point about, knowing 100% of your infrastructure and having good intelligence about the integrity of your current system.
Yeah.
Very good. So the next question, will PRCI consider option of extent pipelines as conduit for J2 service and hosting pull-in relining with HEHCC immune line pipe fabricated on site as pioneered by Smart Pipe Company in Houston? And who will pay for that investigation?
Who will pay for it? It's always the fun question for research. Where's the money come from? No, it's it's one of the topics we're discussing in the Emerging Fuels Institute, and is how do you protect the systems? And is a liner appropriate? Do we use advanced coatings? What we're seeing, and some of the work that Chris Markey's done also at DOE, is some of the things that we would historically use for liners or for coatings really don't buy as much with hydrogen. The size of the molecule of hydrogen permeates through a lot of things more than we thought they would. And that's where we're getting some challenges. And so there has been research done already in some of this space, will these linings or will these coatings work? And the coatings have basically been said probably not. Liners are probably a little bit more not 100% certain yet if they're going to work or not. And some more research could and should be done in that space, but coatings are probably off the table for a variety of different reasons. Even just the applications of internal coatings in operations has been challenging. And so the liners are something that right now, the permeability has been the big suspect because, again, hydrogen molecule is so much smaller than the methane that it is getting through a lot of those things pretty quickly.
Very good. The next question, is PRCI looking to do any collaboration with Hawaii Gas that already has a hydrogen gas production and delivery to its customers via pipelines?
Yeah, that's a great question, Claire, and I don't have a good answer for you. I know we are very familiar, the EFI is very familiar with what they're doing in Hawaii. There's also a good study in the UK about what they've done. Now, some of the apples to oranges comparison, it goes back, I keep saying this over and over again, it's like a broken record, but the pressures and the diameters that they're using for hydrogen transport doesn't match up with onshore activities, what we're doing in the mainland, just vastly different. And when you look to the UK, the design factors they use for their pipelines that they built, because these are the two places that people point to in the most policy discussions. Well, they do it in Hawaii and they do it in the UK. UK pressure and diameters are some of the things we're looking there. In the UK, it's the engineering design. They built the systems back in the 50s, post World War II, and they designed them for all sorts of crud. They weren't sure what they're going to be moving in their product line, and they wanted to make sure they were good. And so they over-designed, which was a common engineering practice at the time. And so the steel factor they have there is vastly different than the thin wall steels that the majority of our operators use in the United States. So the apples to apples comparison is challenging, and it makes it very hard for us to say, let's go spend a huge research portfolio there. But we have begun having discussions, and we do know what they're doing, and we do know how they've operated. We're trying to figure out, can that translate to the mainland more effectively or not with Hawaii? And can we bring that back from Europe to the US or not? That's kind of where we are. But good question though.
Great. The next question is from Steve Cardiff. Would the Research Development Center consider testing downhole inspection tools, MFL and UT, to build a tool performance database for various gas storage, well casing sizes and grades? This would be relevant to underground hydrogen storage.
No, Steve, it's a great question, and we're actually exploring that right now. Is what more do we need to bring on campus to the Houston facility to be able to help us with current assets as well as the future transition for fuel? So no, it's a great idea. And what I'll do is I'll follow up with Lance Abney, who's our manager at the TDC, and know that we're looking at some of this stuff. I'm not sure what, but I'll have him developing an answer. So Steve, if you follow up with me offline, I'll get you a written response back as well. But I believe we definitely would be willing to spend some more time on that. I know we're doing more ultrasonic testing right now with the flow loops. We need to do some more activities for UT and OFL as well.
Great. The next question is from Bill Amend. Hello, Bill. Speaking of collaboration, is PRCI coordinating with the Asme B 3112 committee to ensure that the content of that standard reflects the best current hydrogen research results?
Bill, what are you doing asking questions? You shouldn't be presenting. You should be doing this presentation, not me. But no, Bill, good question. Yeah, like I mentioned before, we are working closely with that committee. It was an interesting conversation with them. They acknowledge they don't have a historical transmission focus because they just haven't had that space. And so now they've asked for us to provide some more volunteers for that. And so we're working with the industry to get some more people to volunteer for the committee. But we'll actually then provide them kind of a recommended document. We're going to try to put it in standard language as much as possible on what we're recommending that the changes be. So that should be something that's happening here in the near future. Like I said, ideally the first draft will be sometime next year. Standards take a while, so it could be in 2024. So we'll wait and see. But yeah, definitely working with them.
Great. Next question is from Cynthia Carter. And I apologize, I can't tell the company that they're with. I'm a rookie at this GoToWebinar system. Any thoughts to share about how hydrogen may affect the storage fields?
And that's been a really good question. And it goes back to a statement Hugo made about if we're doing 100% or we're doing blends, because that's a different question. Is there a separation? If it's a blend, is the natural gas and the hydrogen separate? And if so, how does that impact the storage fields now? And it depends on what kind of storage fields you're doing as well. So there is going to be some significant amount of work this next 2 to 3 years on underground storage. We've got a project we just commissioned with DNV, one of our research partners, to begin exploring some of those topics. But this is a big area because we do need to make sure, and it kind of also goes into the CO2 as well. How do we make sure that we're able to put these new products in the current storage fields? Again, CO2 we've done for a while, so we're feeling pretty good about that. We may need to do more because, again, just the volume. But for hydrogen, it is a newer thing. We haven't done that in a while. We had a big push for hydrogen back in the 70s. Some of you may remember with the fuel embargo last time around, our fuel crisis last time we had. Hydrogen was a big part of our conversation about getting it out of it. And until we didn't need it anymore, that we were doing some hydrogen stuff and had some great research in that space. We needed a little bit more investigation. There's some questions that I don't know if we have all the questions, but that we don't know if we have all the questions for underground storage yet. But we are beginning to do some research now to figure out what that impact's going to be.
Very good. Next question from Tim Rathman. Do you perform HCA liquids and EFRD analysis? And if you do you use ArcGIS for that?
All right, Tim, you have to do the coder ring. You have to know what all those letters mean. I don't think it is for sure. HCA is high consequence errors. I'm not sure EFD analysis is. I'll have to go through all that. Yeah, if you can pop on the line and kind of explain some of those, because I'm not sure that the vocabulary there. I apologize.
We'll see if we can get him on the line. If you can raise your hand, let's see, Tim. Let me see if I can find them. I think while we're getting that set up, maybe we'll skip down to the next question from Bill Ligety again. Do we need a new standard ASME or others for pipelines in VER source, wind, solar, time variable, or hydrogen service, where large and infrequent pressure fluctuations will be inflicted upon the pipeline?
Yeah, that's an interesting question. Yeah, I think the round of new standards will definitely be there. I think ASME is going to have some. I know AMP, which is formerly known as NACE, now AMP, we'll be exploring some of the corrosion aspects because there's going to be some different issues going on because depending, especially if you have this variability of product as the wind and everything, the fluctuation, the pressure fluctuations, there's a corrosion challenges sometimes there too. But I do think you'll see some other standards groups get involved in their areas that are expertise for them. So yeah, so I think Bill, basically I can tell you stay tuned. I think we need to figure out what we need to do. We're still kind of green in this space as far as hydrogen and what all the various repercussions are going to be and what standards need to be changed. Same when we talk about wind and solar and hydro and all those other things. We talk about how do we get those into the systems and begin moving this in a way that makes sense. There will be some opportunities for new standards. I don't know sure which ones there are at this point though.
Going back to Tim, I'm trying to unmute him. Not successful. I don't know if Heather's on. Maybe she can help me. For some reason, the unmute is not working for me.
Yeah, just not sure what EFRD analysis is.
Yeah, maybe Tim, if you can put it in the chat or in the comments.
Yeah, and if not, the idea of HCAs for liquids, HCAs for hydrogen lines definitely will need to be considered. We're beginning to do some research on kind of the impact radius because that's what we base the HCAs on, is what happens if there is a failure, how far away from the pipeline will be impacted. And so that's what creates some of those things and really thinks about that. Also for liquids, the high consequence areas is looking at navigable waterways and other key environmental areas. And so no matter what you do as we manage pipelines, this is always going to be part of our process. What is the area impact radius? What is the challenges around our systems? The operators don't put pipelines just to put pipelines. We're going to put them in areas where we can make sure we can control them and make sure we can run them to the opportunities the best. Yeah. Yeah, definitely.
Tim added some more in the comments there. Yeah.
I see wording down there, exactly. Yeah, no, definitely. We're going to need to make sure, again, safety is going to be the biggest priority in this whole thing. I know that's one thing that's keeping Hugo going is the idea of safety, safety, safety. So when they build this new Angeles link, how do they do this in the most safe way? And rightfully so today, we have to think about kind of the social and environmental impact. So can we go through, historically, unfortunately, a lot of the systems we put through have now had pipe communities develop around them, which is the most best places for systems to be. How do we do this deliberately? Now we're going to build a new link. So I'd love to see Hugo's map to see where they're building the system, but you think about all the construction of homes across the state of California. Where do you put a pipeline that doesn't impact somebody? And how do you do it in a way that makes it the most environmentally and economic and socially correct place to put it? Because we just can't put pipes wherever. We need to be very deliberate about what we do with them. And so I think that's an important thing for us to think about. So yeah, high consequence areas is going to be critical. Looking at for flow restricted devices are going to be important as well. How do we do that? Where do we put that? But as we move into these new fuels, those are the things that I know the operators are really scratching their heads on. And we're doing some research in what kind of impacts, what kind of things do you think about? When you first begin talking to hydrogen to people at a dinner party, as I've done before, they kind of give you the squirrely eye, go, huh, so the Hindenburg, wasn't that hydrogen? And you go, yep. So they go, so you're gonna blow us? I'm like, that's not gonna happen, that's not what we're talking about. But that's instantly, a lot of people in the public, their first instinct is to go what they know, and what they know is Hindenburg. And so that's not a positive situation, and so we're dealing with that. Or if I say, well, we're gonna have this and we're gonna try to mitigate CO2, we're gonna put that in the pipelines. Unfortunately, a more recent failure in Mississippi, they say, well, what about the city here in Mississippi that had this happen? So there's this public perception of some of the things we have to think about. So as an operator, and Hugo can jump in, but safety is going to be the critical part of this story. There is no way you can hide from it. There's no way you can minimize it. It is the #1 thing above everything else. And so when you're building or designing, you're going to think about that first, and then everything else is going to come after that. Has to come after that. We don't have a choice. And the research has to help us to get to as near to 100% perfection as possible. I know it's not attainable, but if we aren't working towards that, we'll never get there. So we have to continue to push towards that number all the time. So 5 nines is good. I'd prefer 25 nines or 100% to get us to that point. I know Hugo is working that ever. I know Ed works that every day to get closer and closer to that 100%. But that's the critical factors we got to do. The last thing I'll close with, I know it's kind of a rambling answer to a question, but one of the things that comes up in conversations, I remember when I first started in this industry 25 years ago, I didn't appreciate that there was an oil and gas pipeline infrastructure that supported me driving to work, me turning on my electricity. I just knew when I wanted power, I flipped a switch. I knew when I wanted to drive my car, I could drive my car. Most people in the world are that way. And until they're pushed to think about it because unfortunate failures or releases have happened, it's not part of the day-to-day equation. Our job is to create a safety program so good they don't have to think about us. That's our ultimate desire. When they have the words pipeline in their mouth right now, unfortunately, it's not a very good taste most of the time. We want that to go away. We want to be so out of mind that it's just part of ethos. Because at the end of the day, as I said earlier, this is the safest form of transportation for energy, period. There's nothing else that beats it. And until it does, that's my trumpet. And got to keep pushing that for our industry.
Yeah, great comment.
Yeah, that safety is paramount first on the list. So that's why we're doing the research, filling the knowledge gaps. So we know, we go in knowing what we know. So it's and safety is top of mind.
Very good. Well, thank you again, Cliff. Fantastic presentation and discussion. Really appreciate your time. And for everybody that attended, thank you for attending and for your participation. Again, take advantage of the information that Cliff shared. And if you want to reach out to his contacts that he shared or the SoCalGas contacts, be happy to talk with you and exchange information and ideas. And thank you all again for attending the webinar. Have a great day.
Ed, Hugo, thanks so much. I appreciate you guys. You guys are awesome. Thanks so much for the opportunity, and be in touch.
Thank you, Cliff. Thanks, Hugo.
Thank you.